Integration by part. In this section, the goal is to develop a general method for attacking integral of the form f of x, g of x, dx. The first step is to let g of x be any antiderivative of g of x. In this case, g prime of x equal to g of x. So, the product rule for differentiating f of x, g of x. I'll start with a function that can be expressed as the product f of x times function g of x. Now, let's take the derivative of this function. It is the first function times the second function equal to f of x, g prime of x plus f prime of x, g of x equal to f of x, g of x plus f of x, g of x. This implies that f of x, g of x is an antiderivative of the function on the right side of the function number 1. So, we can express function number 1 in integral format. Integrate f of x, g of x plus f prime of x, g of x dx equal to f of x gx, or equivalently as integral f of x, g of x dx equal to f of x gx minus f prime of x, g of x dx. This formula allows us to integrate f of x, g of x by integrating f prime of x, g of x instead, and in many cases, the net effect is to replace a difficult integration with an easier one. The application of this formula is called integration by parts. In practice, we usually rewrite a function number 2 by letting u equal to fx, du equal to f prime x dx, v equal to g of x, dv equal to g prime of x dx, or equal to g of x dx. This yields the following alternative form for function number 2. Integral u dv equal to uv minus integral v du.
We will start with a simple example first. Given the question is, use integration by part to evaluate the integral of x times cos x dx. When we got the questions, the very first step is to make a choice for u and dv to put the given integral in the form of the integral u dv. The main goal in integration by part is to choose u and dv to obtain a new integral that is easier to evaluate than the original. There is a useful strategy for choosing u and dv that can be applied when the integrand is a product of two functions from different categories in the list L, I, A, T, E. I am sure you have heard about this method before. Back to the questions. Based on this L, I, A, T, E method, we will let u equal to x and dv equal to cos x dx. The second step is to compute du from du and v from dv, where du equal to dx and v equal to the integral of cos x dx. We get sin x. From the previous section, there is a formula that called as integration by part. The next step is to apply this formula into the questions. What's left now is to solve the simpler version of the questions. X remains as x. The integral of cos x dx is sin x. Minus remains as minus. The integral of sin x dx will get negative cos x plus c. The final answer will be x sin x plus cos x plus c. The reason there is a c here, it is because this is an integration by part for indefinite integrals.
Okay, in this example, I'm going to show you how to integrate x e to the power of x dx. And we are going to be using integration by parts. And I've put the formula here for just a little reminder. The first thing we need to do is to make a substitution. So I'll do it over here. Okay, let's say I let u, in this case u is going to be my x term, and dv by dx equal to e to the power of x. So differentiating u, we will get du by dx equal to 1, and integrating this, we will get v equal to e to the power of x. So x integrating x e to the power of x dx equal to u times v x times e to the power of x minus integrate v e to the power of x du dx is 1 dx. So it got here x e to the power of x minus integrating e to the power of x, simply we got e to the power of x plus constant of integration.
The next example illustrates how integration by part can be used to integrate the inverse trigonometric function. Evaluate the integral 0 to 1 tangent inverse of x dx. So if we take u to be tangent inverse of x, that means du will be dx divided by 1 plus x squared. With that, we have to take dv equals to dx. And so, v will be the integral of dx, which is just x. So put them together by using the integration by parts formula. So we get the integral 0 to 1 tangent inverse of x dx is x tangent inverse of x from 0 to 1 minus the integral 0 to 1 x over 1 plus x squared dx. Simplify the integral by using substitution. We will call the new variable as t. Using the substitution t will be equal to 1 plus x squared. So dt will be 2x. Transform the integral and then we have the integral of 1 over 2t dt. Using these properties, evaluate the integral, which is 1 over 2 ln of absolute value of x. Substitute back t equals to 1 plus x squared. Then we will get 1 half ln of absolute value of 1 plus x squared. When the expression in absolute value bars is positive, remove the bars. To evaluate the definite integral, return the limits of integration. One over 2 ln 1 plus x squared from 0 to 1. Calculate the expression. Simplify the expression, we will get 1 half ln 2. Let's put it back into the first expression. Which is x tangent inverse of x from 0 to 1 minus 1 over 2 ln 2. Let's solve this equation. One tangent inverse of 1 will be pi over 4. Meanwhile, 0 tangent inverse of x will be 0. The final answer will be pi over 4 minus 1 half ln 2.
The next question is integrate x to the power of n ln ax dx with n less than or equal to 2. Next, expand the ln ax into ln a plus ln x. Then we distribute x to the power of n to ln a and ln x. For the integrate x to the power of n ln a dx, ln a is a constant, so we can put it to the left and integrate x to the power of n dx. Next, ln a times x to the power of n plus 1 over n plus 1. For the next part, we have to use integration by part. The first thing to do for integration by part is to find the u and the dv. First of all, to determine the u, we have to use the LITE method. U is ln x, so dv is x to the power of n dx. So du is equal to 1 over x dx, and v is equal to x to the power n plus 1 over n plus 1. Next, you have to remember the formula of integration by part, which is integrate u dv equal to uv minus integrate v du. Next, we have to substitute into the equation.
Next, we get x to the power of n plus 1 ln x over n plus 1 minus integrate x to the power of n over n plus 1 dx. So the answer for this part is x to the power of n plus 1 ln x over n plus 1 minus x to the power of n plus 1 over n plus 1 to the power of 2. The final answer is x to the power n plus 1 ln a over n plus 1 plus x to the power of n plus 1 ln x over n plus 1 minus x to the power of n plus 1 over n plus 1 to the power of 2 plus c.
First, we need to write the question. The question is integrate x to the power of n e to the power of a x to the power of n dx with n is less and equal to 2. Now we need to choose the u and the dv. Useful strategy for choosing u and dv that can be applied when the integrand is a product of two functions from different categories in the list. L. Logarithmic, I. Inverse trigonometric, A. Algebraic, T. Trigonometric, and E is exponential. The reason we choose x to the power of n to be u is because algebraic comes first before exponential. Then you need to do the differentiation for u. And we will get nx to the power of n minus 1 dx. We need to left du on the left side. For the dv, we will choose e to the power of ax to the power of n. And v, we need to do the integration of e to the power of ax to the power of n dx. As you can see, we cannot do the usual integration for the v. We need to use the substitution method. First, we need to let u. To pick the u, we need to pick the hard part to do the differentiation. And in this case, that part is e to the power of a. And then we need to do the differentiation for x to the power of n. The differentiation of x to the power of n is n x to the power of n minus 1. We need to left the dx on the left side. The equation for substitution is integrate u dx. We need to substitute u, which is e to the power of a, and dx, which is du over nx to the power of n minus 1, to get the v. And now we get our u, du, dv, and v. To do the integration by part, the main goal in integration by part is to choose u and dv to obtain a new integral that is easier to evaluate than the original. The integration by part equation is integrate u dv equal to vu minus integrate v du. And now we just substitute the u dv v du into the equation. In the integrate v du, we can see that there are something that we can simplify, which is n x to the power of n minus 1. We simplify those things because we want to be left with e to the power of a. If we integrate e to the power of a dx, we will get e to the power of a back. The final answer is x to the power of n e to the power of a over n x to the power of n minus 1 minus e to the power of a plus c, which is indefinite integral.